Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to be talking about matrices. And this is going to be part one of a series that I'm going to be doing that covers the different things that we can actually do with matrices. First, I want to talk about what exactly a matrix is. So the technical definition is that it's a rectangular array of numbers that are arranged in rows and columns, and this is what we call a matrix. Now inside of the matrix, those numbers that make up the rows and columns are called elements. Some examples of what matrices might look like are these that I have at the bottom of this slide. So I have three different matrices here, and normally if we have a bunch of matrices that we're working with, they are going to use capital letters, like you see me have A, B, and C written there, to differentiate the different matrices. And the reason that they do that is because if you're doing examples with matrices, they will probably put the matrices at the top of the paper or of the section that you're looking at in a book, and underneath it then they would write things like A plus B or B minus C or A times C. So those different operations that we can do with these matrices so that we're not having to rewrite matrices over and over and over again inside the problems and take up a lot of space. So I want to do some practice where first we just take a scalar and we multiply into a matrix. And what a scalar is, another thing to kind of think about with scalars is scale factor. And a scale factor is when you take a number and you're multiplying it into a problem. So it could be a matrix or it could be dimensions of something. And a lot of times a scalar or a scale factor is used if you're trying to dilate something. So if you want to make it bigger or you want to make it smaller. So the first example I have is I'm taking 2 times this matrix 1, 0, negative 2, and 3. And so what I do with this is I take 2 times 1, 2 times 0, 2 times negative 2, and 2 times 3. So you can see how I have that written out in this first problem. Once you've got the 2 basically distributed into that matrix, you just do the math, you just multiply to get your end matrix, which would be 2, 0, negative 4, and 6. Now when you multiply by a scalar, you should not be changing the look of the matrix, so that means you should not be adding any rows or any columns or any extra elements. It should look exactly how it started in the problem. For the second one, I'm taking 0.5 times my matrix. Now 0.5, remember, as a fraction would be the same thing as 1/2. So I'm multiplying by 0.5 or I'm dividing all of my elements by 2. So when you have even numbers like the 4 and the 10, that will work out where you still get a whole number. The 5 and the negative 3 will end up having fractions or decimals for our answers here. So the same process is applied. I'm taking that 0.5 times 4 times 5 times negative 3 and times 10. And so my final matrix looks like this: 2, 2.5, negative 1.5, and 5. The next practice I want to do is with adding, and we'll get into subtracting matrices. When you're adding and subtracting matrices, you want to make sure that they look exactly alike. So I mean that they have the same number of rows, the same number of columns. So all the elements should have another element in the other matrix to match up with. If they do not look the same, if they don't have the same number of rows and columns, then you will not be able to add or subtract them, because you will eventually get to a point where you don't have something matching up between the matrices and you can't do any math there. For example, on this first one here, you can see how both of these matrices have 3 columns and 2 rows. And so you just add up the corresponding elements. So 1 plus 2, 3 plus negative 4, 0 plus 3, that would take care of the top. And then you do the same thing with the bottom. So I have that all typed out there so you can see the numbers that I'm adding together. Once you've got them matched up, you can go ahead and just add them. And make sure that you watch for negative signs, because that will affect your addition. So my final matrix here says 3, negative 1, 3, 2, 0, 5. For the second example, I have smaller matrices that I'm working with here. And so in order to add them, I'm just going to take 5 plus 2, negative 2 plus negative 7, and I get 7, negative 9. Now let's work with subtraction. The same properties or the same rules apply for subtraction that I outlined for addition. The matrices have to look exactly the same in order for you to do the operation. The one thing I would say that you need to watch out for when it comes to subtraction is any negative signs that you see. For this one, I have the minus sign in the middle for the subtraction, but if you look at the second matrix, you should see that -1. Make sure that when you subtract a negative that you realize that's the same thing as adding a positive, so you can kind of change those signs. So when you do this, you want to make sure that you take that negative sign, that subtraction sign, and you just kind of distribute it in to the matrix that follows it. So we're going to have 5 minus a -1, 8 minus 12, and then -4 minus 5. And so we're left with 6, -4, -9. For the second one, if I look at my matrices, the first one has 2 rows, 2 columns. The second one has 2 rows, 3 columns. So I would not be able to subtract these because they don't match. So let's look at some examples where we combine the two things that I've shown you in this video. For this example, I not only want to multiply by a scalar, but then I also need to add them. So the first thing that I would suggest that you do is that you multiply the scalar in. So you can see how I first took 2 times all the elements of the first matrix to get the new one. And then I also did 5 times the second matrix. After that, then you add them. So you do the same math that we were just doing a couple slides ago, where you add those corresponding elements. And so I get 7, -5, 6, 6, 7, and 18 for my answer. An additional example here, again, I'm taking scalars times the matrices first, and then I'm going to end up subtracting them. So I start by taking 6 times the 3 elements from the first matrix, and then I took 2 times the 3 elements from the second matrix, and I put the minus sign in the middle. Now you could also take the -2 times the elements in the second matrix, and then that would change this to an addition problem. If you wanted to change it to addition, you could. Just make sure that if you pull the negative with the number that you multiply in, that you then do change it to an addition problem and don't still subtract, because if you subtract, you're taking that negative and you're applying it twice, and you're going to get the wrong answer. So for the second one, you should get -18, 2, and 38. If you're ready to give it a try, I've created a practice quiz on a website called quiziz.com, and it is a multiple choice platform where you can go and practice the skill you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.